we're going to learn how to run some really cool, highly optimized Rust inside of Dart. And so just kick it off. I'm Brian. I'm an ML engineer at Pieces. I have a background in software engineering and cognitive science. I've done everything in ML from reinforcement learning with drones to now serving LLMs at Pieces. And what my real specialty has been over the last 4 years is figuring out how to serve ML models on basically any hardware that's given to us from a user standpoint. So everything from a pretty small 8 gig RAM integrated GPU machine all the way up to maybe a multi 4090 kind of beast desktop. So yeah, that's been pretty fun. And yeah, in my free time, I do anything besides being at my keyboard. I do enough of that. So I'm outside hiking, camping, fishing, pickleball, and apparently I am an excellent rock, paper, scissors player as well. So that's a great accolade. But yeah, no, let's get into this. So a quick overview. I'm first going to cover, hopefully quickly, what Pieces is, and then really like why our idea, like the idea of what we wanted Pieces to be, drove our choice of choosing Dart, Flutter, and Rust. Then I'll do a small technical deep dive on the 3 of those. Then finally, I'm going to talk about how to actually put Rust in Dart. Not so simple. And then finally, I'll show you a production kind of use case of this at Pieces where we heavily utilize Rust to offset maybe some of the downsides of Dart. So without further ado, let's do it. So yeah, Pieces. So I'll try to keep this quick. Pieces is an AI-powered workflow assistant specifically for developers. And what our goal is to streamline and enhance the developer process across 3 major pillars. So we have research you're doing in your browser. Then we have collaboration tools, so where you're messaging your teammates or sharing resources with them. And then finally, obviously, you're writing code in your IDE. And the problem that we set out to solve really was we have all of these like kind of micro resources that we gather as we're building a project, but you only end up with one big piece of code at the end that's saved to GitHub or whatever your management system is. But you miss out on all of these kind of important small bits of information, like resources, solutions to bugs, small bits of code, maybe messages from a teammate that you're going to need in the future. Like we've all experienced like needing to like find a piece of code that you lost like a month ago. And so what we set out to do at the beginning was create a system that allows you to capture, organize, and enrich those small pieces of information and create what we call like a micro AI repository. And that was great. That's awesome. And so the next phase is like, how do we allow you to find that and use that information again? So like we have a traditional search where you can search by like tags, titles, things like that. But the advent of LLMs like really threw a wrench in things because or not a wrench, or a really nice wrench, because we realized that we could bubble that up in terms of context in your LLM. If you're familiar with the concept of RAG, we use that pretty heavily to surface and bubble up all of your kind of nice micro pieces that you had. And that's really cool. And that's kind of what we did for a couple years. And then we realized there was a big problem in that developers kind of didn't need to know they needed to save like piece of information until it's too late. You didn't know you needed to save that piece of information that Ellie sent me a week ago. And so what Pieces has developed now, and what we're calling our work stream or workflow pattern engine, is that we are proactively saving this information for you. So we're tracking your workflow, and we're going to save that piece of information without you knowing you need to save it, and then we'll allow you to use that as context when you're communicating with your Copilot. And that's been pretty cool. I know this is a bit outdated. It says 6 weeks out. This is in production right now. Please try it out. It's a lot of fun. And I'll leave the rest of these maybe at the end if we have more time for our future kind of plans and Pieces, but let's get into this right now. I know that was a lot of background on Pieces. This is to talk about Dart and Rust. But I think it's important because I think the point I want to highlight is that we set out to build a really ambitious application. We serve on Mac, Linux, Windows. We are extremely data conscious, data privacy conscious, so everything is locked down on your device if you want it to be. And that's hard. Like for people who experience like serving applications, especially building for multi-platform, that's not easy. And then integrating all sorts of AI, it was ambitious. And so the question we asked ourselves, and what I think a lot of development teams ask at the start, is like, when we're picking a tech stack, how do we pick one that is really easy for us as internal developers to develop in, super easy to ship to multi-platform, but still has like really high performance on the back end? And that's how we settled on kind of Dart, Flutter, and Rust. So let's get into it. From a high level, this is our architecture. So we have all of our kind of core logic, 99.9% of our code is there in Dart, and that's great. However, Dart is not extremely high performant. So when we encounter something, a task that needs to be computed really quickly or is compute intensive, or the library doesn't exist in Dart, we kick those out to like extremely optimized, very fast and safe Rust modules, which is really fun. And then obviously we have Flutter powering our front end that's powered by Dart. And before we get into the technicals here, I just want to gauge the room. Who all has experience in Dart or Flutter? Nice. Pieces team, thank you. And what about Rust? Nice. Awesome, that's great. Yeah, I'm not going to cover it hopefully in too deep of information. I'll try to keep it pretty high level for people that don't have any experience in it. So I think this should be pretty good. Cool. So quick overview of Dart. It was developed by Google in 2011. It was originally meant to be their replacement for like more of like a modern JavaScript. But that kind of quickly developed into more of like a full-blown object-oriented programming language that we see today. Their real goal with it was to, like, and they've succeeded, was to develop a language that allows you to deploy a single code base to multi-platforms, so Mac, Linux, Windows, very easily. And then to kind of further that mission of multi-app or multi-platform support, they released an awesome UI development kit, Flutter, in 2017. And Dart is the language that you implement Flutter in. And we'll get to Flutter in a bit. So let's go over the benefits of Dart. So like I said, biggest thing is single code base, multi-platform. And by multi-platform, obviously I mean Mac, Linux, Windows, but this also is mobile, iOS, Android, and then also the web. It is like extremely easy to have one single Dart code base and just compile it for any platform you want. It's just a massive benefit, which is great. So then next, the awesome benefit that Dart has is flexible execution. So there is just-in-time execution and ahead-of-time, or just-in-time compilation and ahead-of-time compilation. And you use these for two purposes. One, so JIT is when you're in debug, and it allows you to quickly make a change in your code and see that in the front end. So you don't have to completely recompile your application. It makes our development cycles like very fast. You don't have to wait 5 minutes for it to recompile. If there's any like C++ or C engineers out there, you know the pain of having to wait for like your dynamic library to recompile for like 10 minutes at times. So this allows it to be instantaneous. But then when you're ready for production, we have ahead of time compilation, which makes the app run extremely fast. The boot up's much faster. It's just high performance. But JIT is awesome, and it really improves our development cycle. So cool. So moving on to the kind of like how Dart isn't the most optimized language, but it does have some ways to make things run fast. And that is concurrency and parallelism, two high concepts. So Dart implements concurrency through asynchronous programming. And for those who don't know, kind of the difference between concurrency and parallelism, concurrency is where you have multiple tasks running on one single thread, and it's kind of intelligently switching or efficiently switching between them. Whereas parallelism is where you have two tasks running on two independent threads, and they're truly running in parallel. Like I think a nice like visualization for this, here's not for those who aren't familiar with the concept, is let's say you're in the kitchen and there's a chef and you have two dishes to make, pasta and a salad. So with concurrency, the single chef is going to go start boiling the water, and while the water is boiling, they're going to go chop some vegetables. As soon as the water is boiling, they're going to add the pasta, and they're going to go back to completing the salad. So I'm going to pop up here. And so that's efficient because they're waiting for like kind of the optimal times to switch between them. And then let's take parallelism. Now you throw two chefs into the kitchen. One is fully dedicated to making the pasta. One is fully dedicated to making the salad. And obviously, you can complete them both much faster that way. But Dart has both of those options. So you can use asynchronous programming, which is great for concurrency, and for parallelism, you can spin up something called an isolate, which is like explicitly dedicates a thread to run whatever task you want. And that's really nice. So cool. So moving on, Dart has awesome core libraries. It's like pretty much everything you need, like that you'd expect from like a modern library. So it has file I/O, math, HTML, encoding and decoding, what have you. So a lot of options there. Integrate. Pub.dev is their library, their site. Awesome things on there. Really nice UI. Simple to find what you need. And then finally, it's extremely easy to learn. It's like, if you look at the syntax of the language, if you programmed in like Java, JavaScript, C#, it's really pretty simple to digest. Like I came from a Java and Python background, and when I started at Pieces, and I picked it up pretty easily within a couple weeks. It was I think I committed my first piece of code on like the first day. So it's really, you can do it for sure. I trust you guys. So cool, let's move to Flutter. So like I said, developed by Google in 2015. It's their open source kind of UI development kit. And yeah, it's built specifically to be deployed to multiple platforms with a consistent UI. And so what does it offer? In that kit, you have all sorts of like organizational layers, so layouts for like lists, rows, grids, things that are like kind of tough to program by hand sometimes. Then you obviously have input fields, buttons, color palettes, things for kind of scrollable lists, things like that. Anything you need for like a modern UI. I know like from talking to our front-end developers, this is a lifesaver for them to not have to rewrite a lot of these components by hand. It's really, and they look nice and they're interactive. So very cool. And then the next big thing is the hot reload. So this is, it says it's thanks due to the just-in-time compiling that I mentioned for Dart. So you can make a change in your Dart code, in your Flutter UI, and it will immediately, once you hot reload, have its impact on the front end. So you can change the color of the website, or you can add a new button, and immediately you'll see the impact. And the development cycle is just very fast there, when you don't need to wait for the entire app to recompile. So that's really nice. And then finally, the super consistent performance across platforms. And that's due to Flutter's custom rendering engine. So a lot of apps, when they're deployed to multiple platforms, they'll have to use kind of native UI components to render. But Flutter has their own. That is like they have complete control over the entire process. And so it's consistent FPS across all platforms, and the UI obviously stays the same. A lot less work, and it's really nice. We love it. Yeah, and a couple examples, who's using Dart and Flutter? The New York Times Games app, so you're playing Wordle, that's Flutter. All things Google, obviously because they developed it. So Google Maps, Google Pay, Google Earth, so the Sonos app, the eBay app, and then most notably, if you've seen the screenshot here, Ubuntu actually said that it is now like the default choice for apps developed for Ubuntu, which is pretty cool. So that's definitely the most notable. That's awesome. But yeah, I just want to do a quick demo now. I don't want to dive too deep into code, so don't focus on the code so much as the ease of setting up a project and developing in Flutter. So let's take a peek at this code. So like I said, if you have any experience in like that kind of a modern language, it's really not too hard to digest here. We have our simple main function that runs the app, and then we have the class for our app that is going to encapsulate the information you'll see below. So we can set our theme here as our theme, the title of the app, and then we create our state. And for this simple app, all it's going to do is a button click, and it's going to count how many times we've clicked this button. And down here, you can see the actual scaffolding for all that. So like I said, it has all of these UI components built in. So centering, columns, text, it's all extremely explicit on like kind of what you need, so very easy to develop in. And yeah, then the incrementing for the counter, the icons. So let's run this. So if I just do Flutter run, it'll boot up here. Yeah, again, the point of this demo is to show like how quickly you can spin up like a really nice app. And yeah, literally, I know it scaffolded a bit here for us with IntelliJ, but it, like as you saw, a lot of this is just comments. This is probably like 50 lines of code, like very easy code to write. So I highly encourage people to try this out on their own in their free time. Yeah, but right now, just compiling the app and it's getting ready to run. Should be booted up any second here. There we go. Cool. Awesome. That's like I said, extremely simple. Push the button. Awesome. Now let's highlight that hot reload, as my friend said there in the back. What I'm going to do is I'm going to use pieces to change the code here. So we have our pieces copilot, and I'm going to create a new chat here, and I'm just gonna copy or highlight all of that. I'm gonna ask pieces copilot and say, change this Flutter app to randomize the color, the background color. Randomize the background color on button click. And we'll get our output here. Awesome, ripping. Cool, so we'll copy that. Boom, and we'll just select all and paste. And then let's see how fast this is. I'm in here and I will do reload. Boom, reloaded, 54 milliseconds. So now when I hit, it actually just added another button. So there we go. It's not exactly what we asked for, but that still proves the example. In 54 milliseconds, is able to completely recompile and show the app, which is pretty cool.
And it remembered your previous state, so it's
exactly.
Instead of having to go back through however it took to get to that page.
Absolutely. So pretty cool. Super simple to use Flutter and Dart. That's our setup example there. All right, so let's go back to. I believe I should have our presentation up, unless Chrome probably crashed as well. There we go. And nice, there we have it. Cool, so let's move on to Rust. That was a quick intro on Dart and Flutter. So Rust, developed by actually Mozilla employee in 2006, and Mozilla kind of picked up the project a couple years later, I think maybe in like 2010 or 2011. But they didn't have their first stable release actually until 2015. That's when 1.0 came out. So it's really new, but it is just, as everyone probably knows, just like spread like wildfire since then. And the employee like originally developed it as like a modern kind of safe solution to C and C++, which is exactly how it's why it's become so popular. And like I said, just rapid growth. It's like they're now up to like almost 3 million developers in 2023. It tripled over 2 years. And according to the end of the year Stack Overflow kind of analysis, it has been the most admired language since 2016. The one just came out again a couple days ago, and it still is. And what they mean by most admired is that when a developer uses it, they would be willing to use it the following year. So 80% of people that use Rust would be willing to go back to it the next year. I'm very sorry for MATLAB developers, only 20%. I have a friend that works in MATLAB and can vouch for this. So let's get into the specifics here. The biggest thing, what everyone talks about, is memory safety. That's the big benefit. And it does so without garbage collection, which is like the kind of the highlighting point here. And a quick background on garbage collection. It's an automatic memory management system or kind of feature that runs in the background. Its main purpose is to clean up memory that's no longer being used, helps avoid memory leaks, and takes the kind of burden of memory management off of the individual developer. So we have languages like Java or Python that have that in the background that are maybe not as performant, but super safe. And on the opposite end, you have things like C and C++, which are extremely unsafe, but very fast. And that's cool. And so how does Rust actually do this memory safety? So they have a unique ownership model. And ownership model kind of defines extremely clear rules for how memory is allocated, used, and freed. And so what they came up with is that each piece of data has a single owner, and the compilers are very aware of who owns what. And when that single owner goes out of scope, that memory is automatically freed. And the important note is that all of these rules are applied at compile time rather than runtime. And so before you can even run your code, the Rust will throw an error and say, hey, that's not a free memory, or that's not a safe memory operation. We're not going to allow you to compile this app, or we're going to throw a warning, which is really nice. Whereas C, you kind of just get slapped in the face at runtime, which is pretty nice. So Rust does this ahead of time, and if you've also ever seen their any output from their warnings or errors, it's incredible, extremely clear. So yeah, so it helps avoid things like use after freeze or double freeze or data races. So extremely safe, really fun. So next major feature is zero cost abstractions. For those who don't know, an abstraction is like a high level programming concept or like construct, like like a vector or a string that is just something like very easy to use if it sits on top of kind of lower level concepts that actually run faster. And so what Rust does at compile time, it's able to take these high level concepts and compile them down as if they're written in these really low level, in the really low level code, and it runs just as quickly as if you did, which is really nice. C++ has a bit of this with like vectors and strings, obviously, but you can still incur, because of the non-compile time checks, you can still incur kind of dangers there if you're not very careful. So, but Rust is ultra careful, so very nice. And then obviously speed. So people come to Rust really for the safety and the speed, and it's able to run as fast as a language like C or C++ because it uses the same exact like compiler techniques, LLVM compiler techniques that generate the optimized code for whatever system you're on. So it's generating extremely similar code to C and C++. And we also, on top of that, it doesn't have a garbage collector that adds overhead. Pretty nice. And then finally, what one of our main benefits of Rust is that it has awesome library support. So because it's a safe and fast language, a lot of people choose to develop their libraries and their APIs in it. So for things like machine learning or image processing or like linear algebra, any of that runs extremely fast, and a lot of people put out support for that. So we heavily utilize that in our app. So who's using it? Basically everyone. If you Google online who uses Rust, everything shows up. It's used in many operating systems. So Android, Linux, Redux, Google Fuchsia. Meta uses it in their control system. Microsoft has all of their Windows APIs bound to Rust. System76 writes a lot of their infrastructure and kind of Linux projects. And then just to list many more, Amazon, Brave, Discord, GitHub, Figma. It's every major company is using it in some way. And if they're not currently, they probably will soon. So I want to do another quick demo. And I'm going to show here how much faster Rust is than Dart. So what I'm going to do is we're going to compute an arbitrary number in the Fibonacci sequence. Fibonacci sequence, for those who don't know, is where a number in that sequence is the sum of the two previous numbers. So 3 was the sum of 1 and 2. Boom, moving on. But yeah, so I'm going to write this in pure Rust and Dart. I'm not going to use any optimized libraries to cheat. And we're going to run these functions recursively and see which one can do it. So let's share a screen here. Nice. So here's our Dart code. We're going to start with this. So I'm computing I'm going to do the 45th number in the sequence. And does anyone have a guess what the 45th number in the Fibonacci sequence might be? 1 trillion. It's like 1 point something trillion. So this is huge. It's a lot to calculate. So I'm just going to do Dart, and then we're going to do main. Oh, sorry. Dart, and we're in Dart, main.dart. Twiddle your fingers a little bit here. Okay. Yep, that's about 7.6 seconds. Not great. Or is it? Who knows? Then we'll go over to Rust, and we'll take a look at our source code here. I've already compiled this library, so I'm not going to redo that here. But you can see the same code. And 45, we're going to recursively call Fibonacci. And let's do it. So we're going to do Rust, target, release, and where the heck is it? Target, release, Fibonacci. That was a lot faster. So there you have it. That was 3.43 seconds compared to 7.6. That's like a 2x speed up, which is pretty incredible. That's raw code. There's no specialized libraries. That's pretty awesome. So that's like the primary example there of why a lot of people use Rust. It's extremely safe, and you get that kind of speed. That's pretty cool. So I've shelled all this out. You can do this in your free time just for the sake of efficiency here. But this is let me expand that. As you can see, this is that nice to have should be function that we want to write in Rust, and that has all the memory safety. And this is what we're actually able to do with Flutter Rust Bridge. We just need to add a couple small nuances here, like the initializing. This app is like kind of a Flutter Rust bridge, dedicated app. You can see all these like the kind of the intricacies of this on their webpage, but it's super simple. We just kind of add a function header here, and then I'm going to run. We're going to do Flutter Rust bridge code generate. Oh, where are we? Oh, I need to, boom, run that again. Super fast, that's awesome. And so let's check out what it spit out. If we go into lib source, it did all of the kind of like nasty like wrapping and safety guarantees and all that for us. And so you can see all these files it generated for disposing and allocating memory and loading the dynamic library. It does all of that for us. And so they generated hundreds of lines of code just for one string. The function was pretty funny. And it ends up with just one function like this, string greet. And so we can now call this directly in our app right here. So we will just do greet or call greet. There it is. I'm now going to put it all together. I'm going to show you how we kind of use this in pieces. I'm going to show you just a live demo of one of our like heavy use cases with inside of pieces. Then I'll highlight afterwards all of the points in which we use Rust, which are a lot, spoiler. So let's do it. Nice. All right. Awesome. Cool. So the piece I want to highlight here in pieces, ironically, which I will open up, is our workflow pattern engine. So where we are proactively saving information for you. And I'll do a quick demo here. So we are going to open up our pieces here. We're going to ensure that our workflow pattern engine is on and operating. And then we're going to enable live context. And so what this is going to do is allow us to not have to manually supply any context, but it should be contextually aware of everything I'm working on. We should be able to interact with that as if it's like your pair programmer knows exactly what you're working on. And so I'll go over to Chrome and we'll go to the Dart, see interop user Dart. So very, very timely one. And so we'll look through this as if we're just scrolling through a doc site. So some cool examples here. We'll see a bit of code. Awesome. And let's say you leave that. And we can go back to pieces. And then what we can do is then say, very generically, say what Dart site was I looking at. There we have it. I just needed a second. So it was fully able to digest and understand everything that was on that page and pull it up in context without me having to manually supply it. And that all happened within like 10 seconds, but we used Rust in so many ways there. So first of all, let me share this again. So what we did, I'll walk you through it and kind of highlight the Rust areas. So we're using screenshotting, and we're locking that down on your device, so no worry about data privacy. So we screenshot your device and your device screen, and we're going to locate information that looks important. So code snippets, links, what have you. And then we're going to put that in a representative format that we're able to look up later. So we're using, for those familiar with ML concepts of like tokenizing and embedding, we're using tokenizing and embedding libraries from Rust, and we are saving that into a Rust vector database, which is pretty cool. And then, what's that?
Quadrant.
Yeah, quadrant, that's right. And we're also, when we take those screenshots, we are using the OpenCV Rust library, and so memory safety. So we're doing things like image cropping, downsampling, anything you want to make the image a bit more like optimized to process. And then after we get our nice image, we extract text from it. That is using currently a C++ library. However, we want to change that to Rust. The library just isn't available yet. And then once we have our nice text, we use an awesome Rust library that finds sensitive information in the text. So we're looking for API keys, passwords, anything like that you might not want to save. And we're using the kind of machine learning models from Rust to extract that. And then, saving it in the vector database. And then we are querying that against what your current question is. using, again, our Rust embeddings. And that's how we're able to generate the context and pass it to the LLM. So within the span of like 10 seconds, we called Rust about like 20 times. And we never could have done that with Dart. We could do it with C, but it's like, but using images and machine learning in C is like very unsafe. We tried to implement a bit of it and dealt with a lot of memory safety issues. And so we settled on Rust, and we've been very, very happy with the results. And I hope you all check that out and are able to kind of verify that yourselves. But yeah, in conclusion, I just want you to know that Dart and Flutter are super, super easy to use. They're an awesome language to use a single code base to develop for multiple platforms. However, Dart isn't the fastest language, but it does expose an FFI, which allows us to offload to really fast languages like C++, C, or Rust. But like I said, C and C++ are not safe. Rust is awesome, but when we want to actually bind it to our FFI, it gets pretty complicated. So we need a tool like the Flutter Rust Bridge to help us do that, and it does that very, very well. And then finally, yeah, Pieces uses like all of these concepts we talked about to allow us to run completely on device and memory safe, and give everyone a great experience on Mac, Linux, and Windows. Thank you. Appreciate it.